Hello student, in previous class I discussed about the quantum number. What is quantum number? Actually quantum number is a set of four numbers that is particularly assigned to an electron in an atom. As a result, it is very easy to describe the size and energy of the cell, say the shape of subcell, orientation of the orbital, and the direction of spinning of the electron. There are four types of quantum number. One is the principal quantum number, second is the azimuthal quantum number, third is the magnetic quantum number, fourth is the spin quantum number. Previous class I also discussed about the principal quantum number. It is denoted by small n. The value of principal quantum number are 1, 2, 3, 4. 1 is your for K cell, 2 for L cell, 3 for M cell, 4 for N cell. There are different significance of principal quantum number. By using the principal quantum number, you can easily you can easily calculate the radius of an orbit. Next, by using the principal quantum number, you can easily determine the energy of an electron in the nth orbit. Next, by using the principal quantum number, the maximum number of electrons in an orbit can be calculated by using the formula 2n square. Next, principal quantum number also says that the value of n for a cell is equal to the number of subcell in that cell. Next, in this class, I will explain about the second quantum number, that is your azimuthal quantum number. What is azimuthal quantum number? It is denoted by L. The azimuthal quantum number is also called subsidiary quantum number, or it is also called angular momentum quantum number. Next, it is called orbital quantum number. Next, it is also called secondary quantum number. Uh, what is the importance of azimuthal quantum number? It is actually used to determine the angular momentum of an electron in an atom. And main point is it explain about the shape of the subcell in which the electron is present. Actually, the azimuthal quantum number deals with the subcell. Next, the azimuthal quantum number value depend upon the value of n. This is the relationship between L and n. Here n is the principal quantum number. Actually, the value of L varies from 0 to n minus 1. 0 to n minus 1 means here I can write small l is equal to 0, 1, 2, 3, 4, dot 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 n minus 1. Suppose if I want to take if n is equal to 1, then put here n is equal to 1. Then here roughly I can write here 1 minus 1, that is your 0. That means here the value of L is equal to 0. If I will put n is equal to 2, then put here 2 minus 1, that is your 1. That means here I can write 0, 1. You can take the initial value, then you also take simultaneously the new value. Here when I put n is equal to 2, here n minus 1, that is your 2 minus 1, that is your 2 minus 1 is your, that is your 1. So here I can take L is equal to 0, 1. So here I can write L is equal to 0, 1. If n is equal to 3, if n is equal to 3, then what happens? Put this value here. N minus 1 means 3 minus 1, that is your 2. That means the value of L is your what? 0, 1, 2. So here I can write L is equal to 0, 1, 2. If n is equal to 4, next put here, you can write here 4 minus 1, that is your 3. That means see the value of L is your how much? 0, 1, 2, 3. So here I can write L is equal to 0, 1, 2, 3. Now here I can write the table. Look at the table. If n is equal to 1, if principal quantum number is your 1, then the value of L is your what? 0. So here I have written 0. Remember when I was teaching you about the azimuthal quantum number at the time, at the time I had um, indicated about some point. If n is equal to 1, that is denoted for k cell. If n is equal to 2, that is denoted for L cell. If n is equal to 3, that is denoted for M cell. If n is equal to 4, that is denoted as N cell. Already this is covered in the principal quantum number. You can call the K cell as a number, that is your n is equal to 1. N is equal to 2 means you clearly you clearly understood that this is all about your L cell. If n is equal to 3 means you clearly understood that this is for M cell. That means by calling K, L, M, N instead of this, you can call n is equal to 1, n is equal to 2, n is equal to 3, n is equal to 4. N is equal to 4. These are the principal quantum number numbered for every cell. Similarly, if you think about the soft cell, if you classify the soft cell, look at that. For K cell, it have one subcell, that is your S. For L cell, it have two subcell, one is your S, another is your P. Similarly, for M cell, it have also three subcell S, P, D. For N cell, it have four subcell S, P, D, F. These subcells are numbered by azimuthal quantum number L. For S value, the azimuthal quantum number L is equal to 0. So here I can write 0. For P value, we can write 1. Similarly, here I can write 0, 1. For D value, we can write 2. So here I can write 0, 1, 2, 3. Look at that. If I will take n is equal to 1, L value is equal to 0, and it is 0 value, L value is equal to 0 represent S subcell. Here the number of subcell is your 1. If n is equal to 2, the L value is your 0, 1. 0 represent to S, and the new value 1 represents to P. Here the total number of subcell is your 2. One is your S, another is your P. If n is equal to 3, then the azimuthal quantum number are 0, 1, 2. 0 already represent to S, 1 already represent to P, the new value 2 is represent now to the D subcell. So, here the number of subcell is your what? 1, 2, 3. There are 3 subcells. One is SPD. Next, if n is equal to if you will take n is equal to 4, then the L value is your 0, 1, 2, 3. 0 already represent to S, 1 represent to P, 2 represent already D, the new value 3 represent to F. Now there are 4 subcells. Each subcell is denoted by the principal quantum number. S for 0, L for 1, S for 0, P for 1, D for 2, S, P, D, F for 3. Next, if you think about the energy of the subcell, let me try to write another important point. We know that K cell have S subcell, L cell have also S subcell with a P subcell. There is a difference, no doubt. The shape of S belongs to the K cell is equal to the shape of S belongs to L cell, both having the same shape, but the size is not same, the size is different. So here I can write this is your 1s, this is your 2s. Here we can write 2p. Here 1 represents to the principal quantum number n is equal to 1, which is represent to the K cell. Similarly, here n is equal to 2, 2 means L cell. Similarly, you can write down for M cell. Here you can write what? Here we can write there are three subcell. One is S, another P, another is your D. Here we can write 3. 3 is due to M cell. M represent to N is equal to 3. Here the principal quantum number is written. Here I can write 3. Here also I can write 3. D. Next, for N cell. Now look at that. Again I want to repeat. There, there are different S cell, different P cell, different D cell. For K cell you can write 1s, for L cell you can write 2s, and for P you can write 2p. M cell you can write 3s. Next for P you can write 3p, 3t. For D cell is 3t, you can write 3t. Similarly for N cell you can write 4s, 4p, 4t, 4a. Actually they are different in the size, not, but they are equal in their shape there. Now let me explain the next point. Suppose you will think about 4s, 4p, 4d, 4a. For the same value, here the value of n is equal 4, here the value of n is equal also 4, here the value of n is equal 4, here the value of n is also 4. These subcell, these four subcell present in the K, that is your same cell, that is your n cell, and it have the value n is equal to 4. So here a point is given for the same value of n, the energy of the subcell are in the following order. That means if 4 the energy of 4s smaller than the energy of 4p, smaller than the energy of 4d, smaller than the energy of 4f. But this point cannot explain about this. That is your the energy relationship between 4s and 3s. This point is not this. Actually, this point is belongs to this example 4s, 4p, 4d, 4f. You can also think about 3s, 3p, 3d. Here you can make a relation according to this point 3s smaller than 3p smaller than 3d. For the same cell, for the same value of n, you can write this relation S having less energy than P, having less energy than D, having less energy than F. Next, you can say that the maximum number of electron in a subcell. The maximum number of electron can be found by using this formula. Remember this point. This is a very important formula. That is your 2 into 2L plus 1. Let me explain. Here we know that for S subcell, L value is your 0. Now we want to find the number of subcell present in the number of electron present in the S subcell. For finding the maximum number of electron in a subcell, here we can put the value of L is equal to 0. Now put here a number, you can write number of maximum electron. Maximum electron is equal to what is the formula? That is your 2 into 2L plus 1. 2 into 2L plus 1. Here we can write 2 into 2 into 2 into again here L value is 0 plus 1. That means here you can write 2 into 0 plus 1, that is your 2 into 1, that is your 2. So here I can write the number of electron is your 2. Similarly, if you think about the P subcell, for P subcell, if you want to target to find out the maximum number of electron present in the P subcell, now think about the azimuthal quantum number. For P subcell, the L value is your 1. So the maximum number of electron is your what? 2 into 2L plus 1. Now put the value of L is equal to 1 here. 2 into 2 into 1 plus 1. Next here you can write 2 bracket 2 plus 1. That means here you can write 2 into 3, that is your 6. So the number of maximum electron in the P subcell is your 6. Similarly, check D having the maximum number of electron is your 10. That means for D cell here you can write L is equal to, that is your 2. Put the value here. Here you can write maximum number of electron is your what? 2 bracket 2 into 2 plus 1 bracket close. That is your 2 into 4 plus 1. That is your 2 into 5 is equal, that is your 10. Similarly, you can think about the F subcell. For F subcell, you can think about L is equal to 3. For F subcell, you can think that L is equal to what? That is your 3. Now put the value here. We can write maximum number of electron is your how much? 2 bracket 2 into 3 plus 1 bracket close. That means 2 into bracket next 6. 2 into 3 means 6 plus 1, that is your 2 into 7, that is your 14. So here 14 electron is present. Again I want to repeat here. For S the maximum number of electron is your 2. For P subcell the maximum number of electron is your 6. For D subcell the maximum number of electron is your 10. For F subcell the maximum number of electron is your 14. It also talk about the shape of subcell. As per this quantum number, S have a spherical symmetrical. Remember, this is an important one mark. In exam, always a question will ask what is the shape of S. You can write spherically symmetrical. When I will teach you about the shape of orbital and subcell, then I will clearly explain what is the meaning of spherical symmetrical. But for this class, only remember S having the shape that is your spherically symmetrical, P having the shape that is your dumbbell shape. Next for D, double dumbbell shape. For F, you can think about the triple dumbbell shape. This is the many significance of what azimuthal quantum number. Another significance is your it explain about the orbital angular momentum of an electron. By this formula, this is the main formula. If you put the value of L, then you can find the orbital angular momentum for each subcell. If you think about for that is your S subcell. For S subcell, you can think L is equal to what? 0. Now put this value here. The orbital angular momentum is means how much? That is root over of bracket root over of L means 0 into 0 plus 1, that is your h next into h by 2 pi. Similarly, you can put the value of L is equal to 1. Then you can put the value of L is equal to 2, 3, like that. You will find the orbital angular momentum. Here h is the Planck's constant, pi value is 3.14. Next, here another point is given, that is the total number of orbital in the subcell. Is actually calculated by the value of 12 plus 1. This is the formula to calculate the total number of orbital in a subcell. Let me explain. Here I have taken S subcell. Our target to find out the number of orbital present in the subcell S. For S subcell, the value of L is equal to what? 0. Now put here, we can write 2 into 0 plus 1. That is your 2. Sorry, 2 into 0 means 0 plus 1 is equal to 1. So here I can write 2 into 0 plus 1 is equal to 1. That means S subcell having the number of orbital is your 1. For P subcell, the number of orbital is your how much? L value is your 1. So here put the value of L here. We can write 2 into 1 plus 1 is equal to 3. Next for D subcell, the value of azimuthal quantum number L is equal to 2. Now put this value here. That is your 2 into 2 plus 1. That is your 4 plus 1 is your 5. So here I can write 5. For f sub cell, the value of L is your 3. Put the value of f that is your L value is equal to 3 in this equation. You can write 2 into 3 plus 1 is equal to 7. So finally, here I can conclude that S subcell having one orbital, that is 1s. P subcell have three orbital. D subcell have five orbital. F subcell having seven orbital. Here you can remember a general knowledge. S is your S for sharp, P for principal, D for diffused, F for fundamental. These orbitals are denoted, and the SPDF means here I have given S for sharp, P for principal, D for diffuse, and F for fundamental. Next, I will move to the magnetic quantum number. Magnetic quantum number is denoted by M or ML. This is the symbol of magnetic quantum number. Principal quantum number related to the cell, azimuthal quantum number related to the subcell. Now, magnetic quantum number related to the orientation of orbitals. That means here I can say that the quantum number that describes the orientation of the orbital is called magnetic quantum number. What are the significance of magnetic quantum number? Actually, azimuthal quantum number L depends upon a principal quantum number n. Now, magnetic quantum number depend upon the value of L. Azimuthal quantum number is your 0 to n minus 1. Now, magnetic quantum number is your m is equal to minus L to plus L including 0. That means here you can write the value of m is equal to 0, comma plus or minus 1, comma plus or minus 2, comma plus or minus 3, comma dot plus or minus L. Here m is the magnetic quantum number, here L is the azimuthal quantum number. Now see the relation how the magnetic quantum number related to the azimuthal quantum number. Let me explain one by one. Suppose I want to take principal quantum number 1. If I will take principal quantum number 1, then the azimuthal quantum number, uh, azimuthal quantum number, here it is not AGN, it is actually AQN. This is your AQN. This is your MQN, this is your substance, this is the name of the orbital. Let me explain. Actually, there is a mistake. This is your principal quantum number. This is your azimuthal quantum number. This is your magnetic quantum number. This is the name of orbitals, and this is the subcell. Before going to this, again I want to give some important information. Here we know that K cell divided into one subcell, that is your S again divided into one orbital, that is called as S. Similarly, L cell having two subcell, one is your S, another is your P. S represent one S orbital. Number of S orbital is your one. P having three orbital, that is your Px, Py, Pz. Similarly, if you think about KLM M cell, it have three subcell. One is your S, another is your P, another is your D. S having one orbital S, P having Px, Py, Pz, D having five orbitals. One is your dxy, dyz, dzx. Next is your d x square minus y square. Next is your dz square. These are the five. Similarly, f having seven orbitals. Look at that. Here I have written fxq, fxq, fyq, fzq, fxyz, fz x square minus y square, fy z square minus x square, fx x square minus z square. These are the list of orbital, name of orbitals. Let me explain one by one. Suppose I want to take principal quantum number 1. The azimuthal quantum number is obviously 0. Now let me find out the magnetic quantum number. I want to try to explain the magnetic quantum number, how it is calculated by using the azimuthal quantum number. Here I have written in relation, that is your what? M is equal to 0 plus or minus 1 plus or minus 2 plus or minus 3 plus or minus L. Let me explain. If n is equal to 1, then the value of L is 0. No doubt. If L is equal to 0, then the value of M is equal to 0. Just remember, after giving 2 3 example, you can clearly understand how these value are calculated. And take another point. If n is equal to 2, it have two azimuthal quantum number 0 1. 0 already covered in the principal quantum number 1. Now let me explain for 1. If L is equal to 1, we put here, that is your 0 plus or minus 1, these 3. So here I can write 1, 0, minus 1. Try to understand, it is very difficult to understand. Suppose think about the principal quantum number 3. If principal quantum number 3, then it have 3 azimuthal quantum number 0, 1, 2. 0 is written as 0, 1 for 3 value, 1 for 3 value, this 0 plus or minus 1, 1, 0, minus 1. If you think about the 2 value, azimuthal quantum number L is equal to 2, here plus or 2 minus is written. That means it's 0 plus or minus 1 plus or minus 2. So I have written plus 2 plus 1, 0, minus 1, minus 2. Similarly, if you think about the n is equal to 4. 4 means it have 4 azimuthal quantum number. One is a 0, 1, 2, 3. Let me explain. 0 for 0, 1 for 3, 1, 0, minus 1 for 2, plus 2, minus 2, plus 1, minus 1, 0. Similarly, think about here. Starting is your plus 3, another is your minus 3, plus 2, minus 2, plus 1, minus 1, 0. Let me explain here. Look at that. If I will take L is equal to 0, then only this will. If I want to take L is equal to 1, then I can take 0 plus or minus 1. From the starting to up to the last L value. Similarly, if you take L is equal to 2, this is your plus or minus 2. So here I can write 0 plus or minus 1 plus or minus 2. If L is equal to 3, you can write 0 plus or minus 1 plus or minus 2 plus or minus 3. This is an difficult term. If you will clearly try to understand, then you will clearly understood. These are the magnetic quantum number. Next, I want to move the spin quantum number. Don't worry for the magnetic quantum number. When I will do different types of problem, you will clearly understood what is a azimuthal quantum number, how they are numbered, what is the principal quantum number, how they are numbered, what is a magnetic quantum number, how they are numbered. You will clearly understood when I will do the problem. Next, think about the spin quantum number. It is denoted by S or ms. Spin quantum number related to the direction of spinning of an electron. Actually, we know that this is the nucleus and the electron revolves around the nucleus in a circular orbit. Each orbital, remember, each orbital having two electrons, whether that belong to S sub cell or P sub cell, D sub cell, F sub. Only remember, electron can spin in clockwise direction. This is the clockwise direction, and electron can spin in the anti-clockwise direction. There are two electrons in an orbit. You can take any orbital of any subcell. Every orbital have two electrons. Again, we know that electrons revolves around a nucleus in a circle in a clockwise direction or anti-clockwise direction. If an electron travel in the clockwise direction, then for that spin quantum number S is equal to plus R. If an electron travels in the anti-clockwise direction, then the value of S is O minus R. This is the spin quantum number. If the electron travels in the clockwise direction, if the electron travels in the clockwise direction, then you can think about the plus R. If the electron travels in the anti-clockwise direction, then S is equal to minus R. Again, I want to try to understand if the electron moves in the clockwise direction, then S is equal to plus R. If the electron moves spin in the anti-clockwise direction, then S is equal to minus R. So here I can write it can have two possible value. S is equal to plus R that denote to the clockwise direction. S is equal to minus R that denote to the anti-clockwise. The two spins are usually designated as arrow mark. Clockwise direction means upward direction arrow mark. Anti-clockwise direction downward. This is your clockwise. This is your anti-clockwise. Clear? So remember, if S is equal to plus R, then you can clearly think about the clockwise spinning, clockwise direction of spinning, and you can think about the upward aroma. If S is equal to minus half, then think about the anti-clockwise spinning and think about the downward aroma. Here I have given some example. If n is equal to 1, then azimuthal quantum number must be 0. Magnetic quantum number is also 0. It have to, suppose think about the two electron, which one is clockwise direction, another is the anti-clockwise direction. So the spin quantum number is your plus half or minus half. If your principal quantum number is your 2, azimuthal quantum number is your 0, 1. For 0 azimuthal quantum number, the value of magnetic quantum number is your 0. For azimuthal quantum number L is equal to 1, here we can write 3 3 magnetic quantum number plus 1, 0, minus 1. And each orbital having 2 electrons. So each magnetic quantum number here denote particular that is your orbital. Each orbital having 2 electrons. So for each I can write plus half or minus half. Plus half, minus half. Here also plus half, minus half. Here also plus half, minus half. From the above, here we can think that since each orbital having two spin quantum number, one is the plus half, another is the minus half. Except these two, there is no chance of the third electron because only two spin quantum number. One is plus half, that is your clockwise direction. Another is a minus half, that is your anti-clockwise direction. So from the above, it is clear that each orbital can accommodate maximum of 2 electrons and their spin must be in opposite direction. Suppose the first electron travel in the clockwise direction, the second electron must be travel in the anti-clockwise direction. Clear? This is the data. From this table, it is clearly confirmed that each orbital having two electron and each orbital having two electron and the two electron must have two different spin quantum number. One is plus half, another is the minus half. By using the spin quantum number, you can find out the spin angular momentum. Spin angular momentum, this is your capital S, these are the small s. Spin angular momentum of electron is capital S is equal to root over of s into, again I want to write here, root over of s into s plus 1 into h by 2 pi. Here s means spin angular momentum. That means the value of s is equal to plus half, s is equal to minus half. Remember an important, whether it is plus half or minus half, always put the value of s without any sign. So here we can write s is equal to half, only half. Don't write plus half, don't write minus half. Here we can put directly the value s is equal to only half. So here I can write s is equal to spin angular momentum. That is your capital S. Small s is the spin quantum number. H is the Planck's constant. This quantum number independent upon the three other quantum number. Already I discussed. Azimuthal quantum number AQN depend upon PQN, yes or no? Because L is equal to 0, 1, 2, 3 dot 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 but n minus 1. Similarly, if you think about the magnetic quantum number depends upon the azimuthal quantum number, yes or no? M is equal to, we can write 0 plus 1 plus or minus 2 plus or minus 3 dot 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 plus or minus L. This is the relationship between magnetic quantum number and L. That is your azimuthal quantum number. Azimuthal quantum number related with the principal quantum number. Magnetic quantum number related with the azimuthal quantum number. But remember, for the spin quantum number, there is no relation with the other three. Only because here only s is equal to plus half or s is equal to minus half. This is the only relation. So it cannot be related to the other three quantum number. So here you can say that spin quantum number is independent of the three other quantum number. Let me give some problem. Before going to problem, I want to say some important point. Let me take another word file. Here we can take another word. Suppose I want to say something. I want to try to understand. Suppose an electron is present. Think about. Suppose an electron is present in K cell and S subcell, S orbital. Let me explain. K cell having one subcell, that is your S subcell, S subcell having also else orbital. What is the setup? And the electron moves in the clockwise direction. Clockwise direction. What is the setup for quantum? Tell me. Again, I want to try to explain K cell. For K cell, n is equal to what? 1. So here I can write n is equal to 1. For S subcell, L is equal to what? 0. So here I can write L is equal to 0. For S orbital, already I discussed M is equal to 0. Remember this formula. L is equal to 0, 1, 2, 3 dot 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 n minus 1. Another formula is your M is equal to 0 plus or minus 1 plus or minus 2 plus or minus 3 plus or minus 4 like that dot 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 plus or minus L. S is equal to maybe plus half or maybe minus half. This is the three important point. Remember L is equal to 0, 1, 2, 3 up to n minus 1. M is equal to 0 plus or minus 1 plus or minus 2 plus or minus 3 plus or minus 4 dot dot plus or minus L. Here we can think S is equal to maybe plus half, maybe minus half. Let me explain. Here the electron present in the K cell. Remember, for K cell, we know that n is equal to 1. Already, K cell is your 1, L cell is your 2, M cell is your 3, N cell is your 4. Already I covered. So here at first I can write the principal quantum number n is equal to 1. If n is equal to 1, put here. You can find out the L value. If n is equal to 1, 1 minus 1, that is a 0. That means here 0, this value. So here I can write L is equal to 0. If you know about the L value, then you can find out the M value. If L is equal to 0, then only this. If L is equal to 2, then we can write 0 plus or minus 1 plus or minus 2. If L is equal to 1, you can write 0 plus or minus 1. If L is equal to 4, then you can write 0 plus or minus 1 plus or minus 2 plus or minus 3 plus or minus 4. If L is equal to 3, then you can write 0 plus or minus 1 plus or minus 2 plus or minus 3. You can take from the initially to up to last. So here I can write for L is equal to 0, M is equal to also 0 because here 0 is given. Now let me explain about the spin quantum number capital S. It is a spin in a clockwise direction. So here I can write plus R. So the actual address of an electron present in the K cell is your N is equal to 1, L is equal to 0, M is equal to 0, S is equal to plus R. Or I can write a set of numbers. By using this number, you can clearly explain about the electron present in which cell, which subcell, which orbital, and it will travel in which, it will spin in which direction, whether clockwise direction or anti-clockwise direction. Let me explain another. Suppose an electron is present in the L cell and it present in the P subcell and it present at the px orbital and anti-clockwise spinning. Anti-clockwise spinning. Then what is the set of four quantum number? L cell. Directly you can write n is equal to 2. If n is equal to 2, let me explain. If n is equal to 2, now put here n minus 1 means 2 minus 1, that is your 1. 1 means 0 1. That means if n is equal to 2, it have a 2L value. L is equal to 0, L is equal to 1. For L is equal to 0, S subcell. For L is equal to 1, P subcell. For L is equal to 2, D subcell. For L is equal to 3, F subcell. Here P subcell is given. The electron present in the P subcell. So don't think about the S subcell. Don't think about the S subcell. Don't think about the D subcell. Don't think about the F subcell. Since here L cell is given, so here I can write n is equal to 2. Since here P sub cell is given, so here I can write L is equal to 1. Since it belongs to px orbital, so here I can write L is equal to plus up. Look at the table. Plus 1, 0, minus 1. Similarly, plus 2, plus 1, 0, minus 1, minus 2. Plus 3, plus 2, plus 1, 0, minus 1, minus 2, minus 3. So actually, the orbitals, three p orbitals present in the p subcell are having equal energy. You can designate with any number, but actually, if you think about the seriality, then gives L is equal to plus one. It is better. But if someone will give L is equal to minus half, or if someone gives L is equal to 0, then it is not wrong. So think about n is equal to 2, L is equal to 1, L is that is your that is your m value, not L value. Again, I want to repeat for L cell n is equal to 2, for P sub cell L is equal to 1, for Px orbital m is equal to plus 1. Since it belongs to anti-clockwise direction, so here S I can write minus R. This is the set of quantum number which is used to denote the electron present in this particular region. L cell, P subcell, Px orbital, anti-clockwise. Think about another point. Suppose a set of quantum number is given. N is equal to 3. Let me explain. N is equal to 3. L is equal to plus 2. Next, M is equal to, L is equal to 2. M is equal to plus 2, clock S is equal to plus R. Then what is the position? What is the address? What is the in which place electron is present? Tell me. N is equal to 3 means for K cell 1 N is equal to 1, for L cell N is equal to 2, for M cell N is equal to 3. So the electron is present M cell. Then look at the other quantum number. Here L is equal to 2, M is equal to plus half, S is equal to plus 1 by 2. Suppose a person will ask to in which cell is present, then you suddenly speak about the M cell because here N is equal to 3 is given. Let me explain which subcell it is present. Which subcell? We know that L is equal to 0, 1, 2, 3, 4 dot dot n minus 1. M is equal to 0 plus or minus 1 plus or minus 2 plus or minus 3 dot dot plus or minus L. Now put here if n is equal to 3, if n is equal to 3, then that is 3 minus 1 is 2, that means it's 0, 1, 2. If n is equal to 3, then it have 3 subcell, 1 is 0, 1, 2. Here 2 is given. If L is equal to 0, then that is denoted at S subcell. If L is equal to 1, that denote P subcell. If L is equal to 2, that is denote D subcell. Next, so here I can say that the electron present no doubt in M cell. But if you think about the deeper study, deeper thing, M cell having 3 subcell. One is your M cell having 3 subcell. One is your 0, 1, 2. So here L is given 2, so you can write that is your D subset. For S is equal to 0, sorry. For again I want to try for S subcell L is equal to 0, for P subcell L is equal to 1, for D subcell L is equal to 2. Here 2 is given, so here I can say that D subcell. Here M is equal to plus 2. D having, again I want to repeat, let me explain. Let me explain. Here M cell, another is a D subcell. Then M is equal to plus 2 represent to which orbital? We know that D subcell having 5 orbital. dxy, dyz, dzx, dx square minus y square, dz square. There are 5 d orbital. Here plus half is given, so you can take dxy. Actually, these 5 orbitals are degenerate to each other. So you can think about any other, any orbital from these 5 orbital. If you think about the seriality, then think about the dx. Look at that. Here I have written, think about the d subcell. Look at that. This table here plus 2. This is the table. Magnetic quantum number plus 2 means dxy. So try to return the document. So here actually what plus 2 is given, so it belongs to dxy orbital. Since s is equal to here belongs to plus half, that is your clockwise spinning. Now tell me actually address of the electron. The electron present in the M cell must be present in the M cell. M cell having three subcell S, P, D. Among the three subcell, the electron is present in the D subcell, and that electron also belongs to the dxy orbital. This is the address, actual address of the electron. Let me think about the another example. Suppose here n is equal to 4 is given, L is equal to 0 is given, M is equal to 0 given, S is equal to plus R. Then what is the address? This address represent to which electron? N is equal to 4 means what? N cell. If L is equal to 0, that belongs to S subcell. If S belong L is equal to 0, S subcell, M is equal to 0, same S orbital. Here S is equal to plus half, that is your clockwise spinning. That means the electron present in the N cell, and among the four subcell, it is present as S subcell, and among the one orbital of S subcell, it present to S orbital. Since here S is equal to plus half is given, so you can think about the clockwise spinning. You can think about any electron and you make a set of address. Let me explain some problem. Look at that. Here some problems are given. Problem number 1. Think about the problem number 1. Here n is equal to 4 is given. That is the principal cell. Find the following. That is your name of cell. Name of cell means that is your n cell. Number of subcell in it. Since here n is equal to 4, again we know that the number of subcell present in a cell is equal to the principal quantum number of the cell. Since here n is equal to 4, so here the number of subcell is your 4. One is S, P, D, F. Next question is total number of orbital in each subcell. Again, I want to say that number of subcell is your how much? 4. What? S, P, D, F. S having one orbital, that is L is equal to 0. S having for S subcell L is equal to 0. So for the S subcell, the total number of orbital in a cell is equal to, this is the formula, 12 plus 1. So here I can write 2 into 0 plus 1 is your 1. So for S subcell, one orbital is present, that is your S. For P subcell L is equal to 1, put this formula 12 plus 1, then you can find 3 orbital. For L is equal to 3, then put this formula 2, yes. Again I want to repeat here. For L is equal to 2, here you can write write the formula 12 plus 1, put the value of L here. That is your 2 into 2 plus 1, that is your 5 orbital. Similarly, if for a F subcell L is equal to 3, now put here 2 into 3 plus 1, that is your 7. So here the answer is for S subcell 1 orbital is present. For P subcell 3 orbital is present. For D subcell 5 orbital is present. For F subcell 7 orbitals are present. So the triple I question is the total number of orbital in each subcell. I have calculated the total number of orbital in each subcell. Now the number of orbital in the principal cell. That means think about the n cell. How many number of orbital present in the n cell? You can add 1 plus 3 plus 5 plus 7. That is your how much? So 7 plus 3 10 plus 5 15. That is your 16. So the answer is your how much? Add all the orbital. Here I can write 1 plus 3 plus 5 plus 7. That is your 16. Next, move to the problem number 2. Find out the four quantum number for an electron present in 3p subcell, 4s subcell. Two questions. One is a 3p subcell, another 4s subcell. At first, find about for the 3p subcell. Your 3 is given already. I have covered this. Uh, no, 3, 2, 2p, 3p, 4s, 4p. These are the principal quantum number. 3p is given. That means your n value is your 3. P is given. For p, L is equal to 1. If L is equal to 1, then it have a 3 magnetic quantum number. That is your plus 1, 0, minus 1. S is equal to what? It may be clockwise direction or anti-clockwise direction. It is not given here. So you can write both values. S is equal to plus R or S is equal to minus R. This is the 4 quantum number. Let me explain about the 4s subcell. Try to understand. Here 4 is written. So here I can write 4. This is your 4. This is your what 4. Here S is given. So L is equal to 0. If L is equal to 0, M is equal to 0. Since here no data is given about the spinning of electron, so it is compulsory to write S is equal to plus R or S is equal to minus R. This is the problem number 2. Next, move to the problem number 3. List all the value of L and M for n is equal to 2. If you think about the L value, let me explain. For n is equal to 2, here we know that L is equal to how much? 0, 1, 2, 3, dot, 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 n minus 1. That means put the value of n is equal to 2 here, 2 minus 1, that is your 1, that is your 0, 1. There are two values, so you are for n is equal to 2, L can have a value 0, 1. For L is equal to 0, M is equal to 0, already I covered. Next, for L is equal to 1, here you can write plus 1, 0, minus 1. This is the answer. For n is equal to 3, for n is equal to 2, you have 2 L value, 0, 1. For L is equal to 0, M is equal to 0. For L is equal to 1, M is equal to plus 1, 0, minus 1. Next, move to the problem number 4. Using S, P, D and F notation, describe the orbital with the following quantum number. Let me explain. Here n is equal to 1, L is equal to 0 given. N is equal to 1 means I can write 1. L is equal to 0 means S. So here I can write 1S. Let me explain to for question number B. N is equal to 4. At first write here 4. L is equal to 3 means remember this point. For S, L is equal to 0. For P, L is equal to 1. For D, L is equal to what? 2. For F, L is equal to 3. Here L is equal to 3 is given. That means F. So here I can write 4F. Like that you can solve many problems, but it is remember these points. For S is equal to what L value, for P is equal to what L value, for D what L value. Similarly for N is equal to 1, which is subcell. This is compulsory to remember, then you can solve the problem easily. Problem number 5. How many electrons in a given atom can have the following quantum number? How many electrons in a given atom? So a quantum number is given, n is equal to 3, L is equal to 1. N 3, write down 3. L is equal to 1 means that is a 3p. So here I can write for n is equal to 3, L is equal to 1, the subcell is a 3p. Maximum number of maximum a formula we have already covered, that is a 2 into 2L plus 1. Maximum number of electron in a subcell, that is your count 2L into 2L plus 1. Now put the value of L here. We can write 2 into bracket 2 into 1 plus 1, that is your 2 into 3, that is your 6 electron. So here I can write for n is equal to 3, L is equal to 1. The number of electron is your 6. Next, move to the other question. N is equal to 3, L is equal to M is equal to 0. It completely represented an orbital. Let me explain. That is your 3. L is equal to 2 means for S is equal to 0, L is equal to, for S is equal to, for S is for S, L value is equal to 0. For P, L value is equal to 1. For let me explain. Look at that. Look at this. Your what? Your L is equal to 2 is given. So think about the D. D subcell. Your D subcell M is equal to 0. You can take any dxy, dyz, dzx, dx square minus y square, dz square. This is your what? Plus 2. This is your plus 1, 0, minus 1, minus 2. Now take your what? M is equal to 0 is given. So think about 3dzx. This is the orbital, and you know that each orbital having 2 electrons. So let me explain the answer. N is equal to 3, L is equal to 2, M is equal to 0. This represents an orbital of 3d subcell. Yeah, I have written 3 zx. We know that each orbital has maximum 2 electrons. So here we can write for N is equal to 3, L is equal to 2, M is equal to 0. The number of electrons is equal to 2. This is the answer. Let me explain the problem number 6. What is the value of orbital angular momentum of a 3D electron? Orbital angular momentum formula is what? This is the formula h by 2 pi into root over of L into L plus 1. 3D electron is given. 3D electron means here N is equal to 3. L is equal to what? 2. Now put the value of L here. Orbital angular momentum is equal to h divided by 2 pi root over of L into L plus 1. Here I can write h by 2 pi root over of 2 into 2 plus 1. H means that is your Planck's constant, that is the value is your 6.62 into 10 to the minus 34 joule into second. Now put here the value of H, this is the H value, clear? And if you solve this, then you can find root over of 2 into 3, that is your root to 6. Here I have given root 6, that is your joule into second. And the here 2, pi value is your 3.14. So finally, after calculation, you will see 2.57 into 10 to the minus 34 joule into second. So here I can write the orbital angular momentum of 3D electron is your 2.57 into 10 to the 34 joule into second. This is all about different quantum numbers. These are different types of quantum number already I covered. Thank you very much everybody for watching the video. Namaste.